Hello, this is Ray with Key doing a quick tutorial on calculating average atomic mass. So obviously you'd want to write these down. Actually, I think a friend wanted me to sing this for you. There we go. So now you know that you're going to write this down as we work the problem. That'll help you remember how to do it in class and on your test. So finding a piece of carbon in nature, it has isotopes. There's 3 different isotopes we'll find with carbon. Their percentages are 99% of that chunk of coal is going to be carbon-12. 0.90% is carbon-13, and of course carbon-14 is found at 0.10%. So how do we actually get the average atomic mass using these percentages? Well, we first need to do 3 calculations, and we do those calculations by taking it out of percent. So how do you take a number out of the percent? You move it 2 places. So I'm going to move that decimal over there, and I'm going to multiply 12 times 0.99, and I'm going to get an answer of 11.88. Okay, I'm going to do that same thing this time. Be careful. When you move the decimal 2 times here, you're going to have 2 zeros. So that's going to be 13 times 0.0090. And that's going to give me a really small number of 0.117. Lastly, move the decimal 2 places and multiply that out, and I'm going to get another really small number of 0.0141. Okay, when I add these numbers together, I get a number of 12.011. And that can be an AMU, atomic mass unit, or very simply just grams, which I prefer just calling it G. That was really simple and really easy. You may want to pause it to finish writing that down. But one of my favorite problems is when we give you element X. Now please, don't look on the periodic table for element X. There's not one. There's Xe, but not just an X. So I'm going to give you a mystery element, an unknown element. And I'm going to give you 4 isotopes on this one. Okay, how do we find not only the average atomic mass, but also the name or symbol for the element? Well, let's do this together. So again, we're going to move that decimal 2 places to get it out of percent. We're going to multiply it together, and we're going to get 3.132. Same thing here. You're going to get 51.3632. I have students asking all the time how many decimal places. For these problems, because I'm looking for an element, I like to take it out to at least 4 decimal places if I have that on my calculator. Lastly, 2.2 percent. I'm going to move my decimal 2 places, and I'm going to get 1.254. And the last one, 2 zeros, 0.1624. Add all of these together, all 4 numbers together, and you get 55.9116. Again, I'm going to just, you could call it AMU, atomic mass unit, or grams. I prefer the grams, it's just easier. All right, now, wait a minute. So we're supposed to predict on the periodic table what element has a mass of 55.911. So I'm going to grab my handy dandy periodic table and go searching. So when I look, I find that iron is 55.845, and that is absolutely the closest element to it. So my answer is, you could write the symbol, or you could write out the word that X stands for iron. All right, now, students are always asking, how do I use this in the real world? Well, average atomic mass is the exact Same thing as calculating your average in chemistry. So let's pretend for a second. We're going to make it real. Here are your grades and how we're going to calculate them. All of the percents which come off the syllabus are right here. Pretend your average here is 80 for your seated test. We're going to move that decimal 2 places just like we had before and multiply 30.35 times 80. And when we type that in, we get that number to be 28. Next, 2 places, multiply it across, we get 18. 2 places, multiply across, we get 16. And of course, that would be 25. Let me show you, I moved my decimal there. When you add all these numbers up, you get 87 for your grade. Whenever we have a progress report, we'll allow you to use your averages in the columns to see how accurate the number is given to you on your grade. So keep this information handy, so when you get your first progress report, you'll be able to calculate to see within how many decimal places the computer is accurate. Hope this helped.